for signing up and joining for this Future Homes and Building Standards Consultation presentation. I'm Ellen Hewlin from Whitecode. I am Sustainability Director. I'm hopefully going to be joined by Alex Hill partway through the presentation. He's just rushing back from London, so if he doesn't get back, I'm going to also do his part of the presentation. Here we go. Right, this should work now. Yeah, so in terms of the agenda, I'm going to be looking at the timeline, where we've come from and where we're going in terms of the Future Home Standard. I'm not going to just go through the whole of the consultation because there's a lot of information in there, and to be honest, there's lots of information you might not be interested in, you might be interested in. I'm going to do sort of a top level review of it and hopefully pull out some of the really interesting things that are going to be relevant to you going forward for the Future Homes and Building Standards consultation. I'm also going to look a little bit about heat network connection, focus a bit on non-domestic targets as well, look at material change of use, so conversions, a little bit about the home energy model, and then hopefully Alex will be along to look at the energy issues as we move through the Future Home Standard consultation. So to start with, just a bit of a timeline and what's been happening recently. So a lot of you obviously know that Part L 2021 was released on 15th of June 2022, quite a long time ago now, but actually a lot of our schemes are still going through this transition period where they've locked into the previous regulations. So it's only been the past sort of year or so that we've seen our schemes and our clients starting to work to these new regulations for Part L 2021. Part L 2021 was really set up as a stepping stone towards these future home standards. And the Future Home Standard was first conceived back in 2019 as part of the Spring Statement. The government put forward that by 2050, all homes will be built to this Future Home Standard. Well, 2025, actually, this is when the Future Home Standard is going to come in. The consultation for the Future Home Standard was published back in December, and it's actually closing next week on the 6th of March. So during this time, we've all been busily reading the Future Home Standard consultation to find out how we're going to have to build our buildings over the next few years. Then there's a bit of a period where the Future Home Standard consultation will finish. They'll publish the Future Home Standard, but our net goal really is obviously to get to net zero carbon by 2050. When we had the new building regulations that were published in 2022, alongside that came the updates to Part F for ventilation, obviously Part L for energy. We moved over to SAP 10 and also Part O for overheating and Part S for electric car charging. So that was quite a big change then. And I think a lot of people are still trying to get their heads around those changes as we swiftly move forward to 2025 and the Future Home Standard. The main thing here as well is that we've actually made a legal agreement, the government have made a legal agreement to meet net zero by 2050. So we've got to accelerate this carbon reduction quite quickly to achieve this. So this is where we're at the moment. I've put another timeline in, and this is specifically to do with what's going on with the Future Homes consultation. So in December 2023, as I said, they released this consultation. And it very much gave the sort of roadmap to what we're going to do over the next few years in terms of energy compliance for new buildings and conversions. And during that time, we've been reviewing it and having a look at it. Everyone can provide responses by the 6th of March. So if you feel strongly about any of these items that I'm talking about, get on the website and respond, because every sort of response is important, no matter how big or small it is. So we're preparing a response to submit at the moment, and by the end of 2024 we're expecting a new set of approved documents to be issued, so a new Part L basically, which is going to be based on the Future Homes and Building Standards. Also this year potentially we're going to be having a general election, so this may affect it. Those of you who know about Part L 2013 and how long it took to get to Part L 2021 will know that potentially this could become a bit delayed as well. So they've allowed either 6 or 12 months, depending on how the industry is responding, before they actually put the Future Home Standard into place. So sometime in 2025, either probably in the spring, more likely I'd say autumn 2025, the Future Home Standard is going to come into force, which means that all your building sites that have not already started on site are going to need to comply with this. So it's really important to be thinking about this now if you're thinking about putting plans in for planning permission to ensure that you future-proof yourself for Future Home Standard in 2025, because potentially schemes you're putting in now are going to be built out in 2025 and beyond and need to comply with this regulation. As always, there's going to be a bit of a transition period with Part L as it enters, and it's going to be a 1-year transition period from the implementation of Future Home Standard to allow everyone to sort of catch up. Now, the key thing here is that the definition of commencement has been changed. Bearing in mind, this is all in consultation, so this is what they're suggesting. Previously, you could put things in like pipes or drainage, and that could be defined as you've commenced that plot. It's on a plot by plot basis, but now it's likely to be foundations and lowest floors need to be installed before you can actually say that you've commenced, and that needs to obviously be agreed with the building control officer. So if you've got a site where you've got 200 units, it's quite possible that you're going to have some units under the old regulations and some under the Future Home Standard. So it's very important that you plan this when you're looking at your schemes and what you need to do. There's another thing here that we need to talk about is called the sunsetting of 2013 and 2010 regs. So what they've noticed is through to the transition period before and also getting that initial start, there were some schemes which, I mean, we've got some actually that have been registered under 2013 because they've got that start in place. They still haven't been started building. So potentially by the time they're built, they're going to be 10 to 15 years out of date, using things like direct electric heating, not being insulated to the proper standards. So the proposal is to sunset the 2013 and 2010 regs. And this could potentially mean that the Future Homes and Building Standard will apply to all new buildings, regardless of whether the site has previously benefited from transitional arrangements. So that is quite a big change and means that particularly large developers who have sites where they're trying to maintain the same regulations across the site are going to come a bit unstuck because essentially we're saying you can't build under the old regulations anymore. So yeah, that's interesting. And we're obviously going to see how this transition period plays out. Those of you who know a bit about SAPs and SAP compliance will be happy to hear that in terms of the targets we need to meet and the metrics we need to meet to comply with the Part L haven't changed. So we've got the target emission rate, which is carbon, target primary energy rate, which is to do with energy, and the target fabric energy efficiency. And that is to do more with the fabric of the building, U values, air permeability, thermal bridging, things like that. So they are going to remain in the Future Home Standard as the 3 metrics for compliance for residential. Those of you who work with non-domestic buildings will know it's called the BER, so the building emission rate, and the so that is going to be applied for non-domestic buildings. There's no fabric energy efficiency required currently for non-domestic buildings. The reason for that is actually the fabric has much less of an impact on compliance than it does in residential. It was considered perhaps to use an energy use intensity metric to comply with, and this would be looking at regulated and unregulated energy for compliance. Regulated energy being your heating, hot water, pumps, fans, lighting. That's all included in what we now know as the SAP. And the unregulated energy, which is everything else in the dwelling that uses energy, mainly electricity, but could be gas if you're using gas for cooking. So cooking, appliances, all your plug-in equipment, and in apartment blocks, it's things like lifts, escalators and things like that. But they decided no, they didn't want to include that. And I can understand why, because really that's very much based on the people that live there and their usage patterns. So it's very difficult to regulate unregulated energy because, by the words of it, you can't actually control how people use the building. So yeah, that's a bit of the timeline. What do we think a compliant new home is going to look like post 2025? Now, as I said earlier, we're in the consultation period at the moment, and when it finishes, the government's going to gather everyone's evidence together, have a look at it, and work out how they want to progress this and how they want to make homes look post 2025. There are 2 options here, so there's quite a lot of information on this page. So to look at the U values first, what they've decided to do is actually not really change the U values for your thermal elements from 2021. So those of you who might specify U values, wall insulation, things like that, you're probably thinking, oh, to be honest, we do this at the moment, really. So an external wall of 0.18 isn't that unusual. What we had expected to see was more a lower window U value, so move to triple glazing, but they've actually kept the U value of the window at 1.2. So in terms of fabric, there isn't going to be much change to what we're doing now. I think really the biggest change that's been recently was the step up from 2013 to 2021. That wall U value and that increase in wall, insulation in the wall has been quite significant. So yeah, in terms of that, there's going to not be much change. You'll see here the heat source is air source heat pump, and that is the case for both options. I'm going to explain a little bit about the two options in a minute, but essentially when we've run trials on this with the software, air source heat pump is basically the only heating source that works. So there's obviously a few different types of air source heat pumps, but we're really now being pushed down the air source heat pump route. Hot water cylinders, we're going to need a minimum of 120mm insulation. So again, that's a bit of an uplift. And then we split into the two options. So looking at option one, which is the left-hand column, we've got a slightly lower air tightness and using some sort of mechanical decentralized MEV, or you could use obviously a whole house extract or MVHR. But the notional would contain decentralized MEV. It also contains wastewater heat recovery, which collects the waste heat from when you have a shower and bath and things like that. So that would also be included in option one. The main difference between option one and option two is the inclusion of PV panels at an area of 40% of the ground area. So when we're talking about option one and option two, these are essentially recipes for compliance. Option one has additional upfront costs for the developer because they're going to have to install the air source heat pump. They're going to also have to install the PV panels to comply. When we're looking at this table, this is basically the minimum you're going to need to comply. So the change to air source heat pump, lots of our clients have obviously gone down that route already with the London plan and things like that. But the air source heat pump and PV panels is option one. Option two is just the air source heat pump, no PV panels. So it's a more of a minimal approach, less upfront cost for the developer, but you'll see in a minute, more expensive to run for the occupant. So this is the options that they're giving you in the consultation. Would you prefer option one or would you prefer option two? I think there's going to be quite a split down the middle in terms of, thinking about costs and things like that, but an interesting thing to talk about. I put there gas and direct electric will not comply. So we haven't really been using it so much, but outside of London, we can use direct electric under Part L 2021 and it still complies at the moment. If you have, if you add some other stuff to it, but for 2025, there'll be no gas, no direct electric. And as I said here, option two requires PV panels. And I put the question here, should PV be mandatory? Well, they've also added into the guidance that if you've got a large apartment block with 15 stories or more, it's proposed they won't include the PV panels in the notional dwelling because of the way that it's set up. So yeah, tall apartment blocks won't be required to have the solar panels. And those of you that have applications in the London area will know that generally speaking, we need to fully fill roofs with PV anyway to comply with the London plan. I won't go into it massively now, but it's likely the London plan wording is going to have to change in terms of energy because what we just looked at there is currently achieving around 50% in Part L 2021. Under the Future Home Standard, that's basically just going to scrape a pass. So we're not going to be able to achieve that extra carbon reduction that the London plan asks for. So they'll have to change something there to fall in line with the Future Home Standard. The other thing about PV, and looking just a little bit at houses specifically, is that if you're looking at 40% floor area of the house, the ground floor area, you've got a 3-story house, a bit like this one, with some dormer windows in the roof. The ground floor is 40 metres squared. You need 40% of that to comply. So I think that's the right amount actually, but you're going to basically need a certain amount of PV to comply with the air source heat pump and PV strategy. And if you've got things like dormers or you've got east-west roofs and things like that, it's actually going to be quite challenging, I think, to meet that 40% requirement on your roof. So that's also something to think about. And I think we will be responding and saying we need to consider that it's not always possible to get your 40% floor area of PV on your roofs, depending on your design and orientation of the dwelling. I think in terms of the options, I personally would prefer to move into an option one house where you've got your air source heat pump and your PV together. And I'm going to show you why now. Because how much is it likely to cost? So these figures have been based on a 3-bed house. And this is information that has come from the Future Home Standard consultation. So they've done a bit of a cost analysis and I've basically just taken the numbers straight from there. So I didn't work these out myself. But we've got a few different options here of different houses that you could live in. So typical existing home, a 3-bed house that someone currently lives in. And then we've got the Part L 2021 compliant homes. So these are homes that are being built now against Part L 2021. And they've used the baseline for this as a gas boiler, because that still complies under 2021, and PV panels. So some of our clients have switched straight to air source heat pumps for compliance, but for this case, it's assuming that the Part L 2021 compliance scheme has gas and PV. Then we've got the two options I just talked about for future home standard. We've got the first option, which is air source heat pump and PV. You can see a nice little picture of it there. And then the second option, which is just the air source heat pump. So looking at bills to start with, how much is it going to cost the occupant? So they've said around 1,500 to £2,500 currently to heat per year, heat and hot water for a typical existing home. And we're probably assuming this is going to have a gas boiler, might be a bit of an old gas boiler, but it's probably not a very well insulated home. And this is about how much it's going to be costing at the moment. My bills are much higher than that, so not entirely sure on that. Someone who's moved recently into a brand new Part L 2021 compliant house should be expecting to pay £640 a year. That's probably because they've got the PV on there. So it's still a gas boiler. And don't forget, Alex is going to talk about this in a minute. Gas is obviously much cheaper than electric. So we've got a gas boiler and the PV. So it should only be £640, which is, less than half what you'd be paying now, if not better. Now, to make future home standard option 1 or 2, there's going to be some cost to the developer. This is the approximate cost of the developer to upgrade to option 1 with an air source heat pump and PV. And then this is from upgrading from the Part L 2021 one, by the way. So adding an air source heat pump when you've already got the PV, it's an extra 6,200. And then you've got just add the air source heat pump, but not have the PV is an extra 1,000. So it's a higher upfront cost for the future home standard and option 1, which was obviously results in much lower bills. So for option 1, we should see a further reduction in the heating and hot water bills for that option at 520. Bearing in mind, we've fully switched to electric now, so we've got no gas. And that's because you've got the PV. However, if we go for option 2, our bills have gone up massively. And this, if we go for option 2, this will be the first time ever that a change to the Part L building regulations has resulted in higher bills for the occupant. So I think there's a lot to think about here. When you've got an air source heat pump, and Alex's section goes a little bit more into this, that the cost of the occupant is going to be much higher. If you had your existing home you live in, if you want to upgrade it to the same standard, you're looking between £11,000 to £12,000 to get the air source heat pump and PV. This doesn't include any upgrade to your fabric though, and obviously if you were going to put an air source heat pump in, we'd recommend you upgrade your fabric too. So hopefully that gives you a bit of an idea about what the options are and how much it's going to cost. That sort of covers off the residential side. The other thing I wanted to talk about was the other option for, aside from air source heat pumps, is connecting to this wonderful heat network that we're going to have everywhere, connecting everyone wonderfully together, and we're all going to plug in lovely. This in the background is a shot of the London heat map, and you can see here some of the existing and proposed district heat networks that are in London. Now, this is right in the centre of London, and the red ones are the ones which actually exist, and the purple ones are the proposed ones. So they're quite sporadic, and majority of there are actually purple, so they don't actually exist yet. Our experience of trying to connect to existing heat networks is it's quite difficult to do. There's quite a lot of hoops to jump through. I was going to say rope to jump through then. Hoops to jump through to make sure that you can connect to it. However, obviously it needs to be part of Part L because it's being really pushed, especially in the London plan. So there's also a table that I put in here, which is the compliance if you're specifying a heat network. Everything else in option 1 and 2 remains the same, except the heat source, which rather than having an individual air source heat pump or a heat network, a site-wide heat network, you connect to a 4th generation heat network, basically air source heat pump. And it has some minimum requirements, like the SCOP needs to be 3, and then it has, if you have really high primary losses, obviously it's going to count against you. So again, this is saying is it needs to be a heat pump. There obviously are existing heat networks around London. You can see that I showed you in red there. A lot of those have got gas-fired CHP, so you'd only really be able to connect to those if they start to decarbonise the heat networks and add in air source heat pumps and things like that. Otherwise, yeah, you won't be able to connect to those existing networks. So again, it's interesting to see what they're looking at. Whether it will actually work out in terms of heat networks, we shall see. Just to go then into non-domestic buildings. So with non-domestic buildings, the consultation is split between top lit buildings, which is like your warehouses, and then side lit buildings, more standard commercial buildings like offices, schools, things like that. So there's a couple of different requirements for these because they are quite different types of buildings. In terms of fabric standards, they're going to be, as we've seen with the residential, are going to be staying as 21 standards. There's going to have to be an enhanced air tightness for the top lit buildings. In terms of heating, you will be able to have radiant electric heating in the top lit buildings because, again, then they're sort of used for storage and things like that normally. But it will be air source heat pump for the side lit buildings like offices. This is not unexpected. Most offices have air source heat pumps, and new build offices have air source heat pumps now anyway. So these sort of things aren't unusual. There will be an increased lighting efficiency required up to 105 lumens per circuit watt as the minimum, and also an enhanced heat recovery efficiency. So these are the sort of standard assumptions. But again, there's going to be two options like we had for residential. So this is option 2, but it's the least preferred option, and it's to do with PV, and it's to do with the percentage of floor area again of PV that's going to be required. So for top lit buildings, we're looking at the area of the foundation slab. Basically, you need 40% to comply. For side lit, it'd be 20% to comply. What they've said in the consultation is they'd actually prefer this option, which is the option number 1, which is 75% for top lit buildings and 40% for side lit buildings. So they're pushing people down, saying, you know, we need to maximise the amount of PV on commercial buildings as much as possible. So I think really, in terms of future home standard, it's not a massive uplift to what we're currently doing. It's just this extra PV requirement, which isn't included at the moment. And there's a big opportunity to improve the PV, improve the energy efficiency of buildings by adding PV to them. So this, again, will be in the consultation. People will be providing their comments to say, yes, we think option 1, this is why, yes, we think option 2. It looks as though it's going to go down option 1, which is the maximised PV. In terms of services, there's this is the services for both, some is for residential, some you can see is there for commercial, but there's the minimum coefficient of performance that is proposed for the heat pumps in the residential side is 3.5. That's quite high. Do we think many heat pumps can actually achieve that? Alex might have something to say about this later. Yeah, so that's what's going to be going in as the minimum standard for heat pumps in residential, 2.5 for commercial. As I said earlier, we will need to improve the lighting to 105 lumens per circuit watt. That is also for residential. So at the moment, when we're doing our Part L 2021 calculations, we're putting in probably about 80, 90 lumens per circuit watt, maybe 75 to get compliance. That needs to improve. In terms of insulating pipes, we love that here. So we do actually normally insulate to SIB CCP1 anyway, but that's now going to be looking to become part of the Part L regulations to really improve that and make sure the heat losses are minimised through distribution network. In terms of commercial buildings, they are now proposing to include minimum efficiencies for lifts and escalators. Before, these fell outside of Part L, and to be honest, no one was really looking at how much energy these were using. But in a large commercial building, they can be quite a high percentage of the energy usage. We do a lot of BREEAM assessments, and we do actually look at energy efficiency of lifts and escalators in there. But what they're proposing is to bring it in to the Part L, so that there's going to be an incentive then for people to select low energy lifts and escalators. So yeah, there is more information in the Future Home Standard about services if you're really interested to go and have a look. But these are just some of the top ones that I thought would be interesting today. I just wanted to touch a bit on materials change of use as well. So for a very long time, for material change of use, which is essentially changing the use. So for example, going from an office to a dwelling, for a very long time, all we've had to do for material change of use is just meet minimum standards for building fabric and building services. So we'd have a set of U values and we'd say, yeah, we're just going to build to that, that'll be fine. And quite often we'd say, oh, actually, we can't insulate that wall here, and do a bit of an offset payment, offset calculation, sorry, to show that it was not technically feasible. So there was a bit of wording that mentioned that. And so a lot of buildings actually are being built with quite poor insulation, and also because they didn't have to fully comply with SAP, they were putting in electric panel heaters, electric immersion heaters, and actually costing the occupant quite a lot to run those buildings. So yeah, as I said, this is what we've been doing for a long time. The proposal for the Future Home Standard is to move to a whole building approach, a bit like we do for new builds. So it's not just going to have to comply with minimum building fabric standards and minimum building services. It's actually going to have to essentially pass the energy calculation. So looking at it as a whole, because there was definitely some gaps in the material change of use, which was actually producing some poor, not all of them, but some poor conversions. So there's also been some discussion around should low versus mid to high rise conversions be considered differently. So here is another table. So as you can see, there's a lot of numbers in this consultation. I've tried to make it as digestible as possible, and I'm happy to send this out afterwards for people to have a further look if they want. This is just to compare what they've suggested for materials change of use. So the low rise versus the mid and high rise conversions. There's a little bit of difference in the U values, so the target U values, whether you've got something that's low rise or mid to high rise, just because it understands that it's easier to make adjustments if you've got more wall space to do it. So it looks like the U value for the external walls is going to have to come down quite significantly. If you've got a solid external wall, your U value for that could be about 2.1. So to improve it to 0.18 or not is obviously quite hard. So it's more likely if you've got a solid stone wall, for example, it's more likely to be a low-rise building. Sorry, I went around about that bit the wrong way. But yeah, so if you've got a solid wall and it's a low-rise, it's quite hard to insulate that. So hence why the U value target is not as hard to achieve. So it's 0.3. If you've got mid to high rise, it's more likely to be more easy to insulate that and improve the U value. Again, the windows at a 1.2, this is likely to be, if you've got an old building, these are going to have to be windows are replaced unless there's any particular listed or historic requirement. And again, you can see heat source is mainly air source heat pump, but for mid to high rise, they are looking to possibly allow electric storage heaters, just because of the way that the size of the building, then it might be more appropriate to do that. So I think probably this is the only place we're going to see electric storage heaters or electric panel heaters come through to be allowed is in mid to high rise conversions. All the rest of the things are pretty much the same, and they've also they've said wastewater heat recovery if it's low rise, it's trickier for high rise, and then PV panels 40% of the ground area. Just a note on apartment blocks, it's 40% of the ground area, and then it's worked out by the number of stories in the block as well, so it's prorated. So yeah, there's lots of information there, but I think the key takeaway for material change of use is that really they want to improve it as close to a new build as possible, because there's been a lot of conversions that have been substandard. They're also thinking, could we possibly use the BREL, which is essentially the SAP calculation, so getting full compliance. And they've also considered, and I haven't really mentioned about overheating much in this presentation because it's really focused on energy, but they're considering bringing part O into conversions as well. So at the moment, part O is just related to new builds, residential, and things like student accommodation, but they're thinking about bringing this into material change of use. I think this is a good idea, to be fair, because a lot of, say, conversions from office buildings have quite a lot of glazing and are single aspect, so actually they don't get a lot of cross ventilation. So I think that they have recognised this is potentially a problem in material change of use, and so potentially it's looking like overheating might be added in as well, although they're not currently consulting on part O, they're just consulting on future home standards. So it won't be soon, but I think in the future it may be. So that sort of covers all the changes to how we're going to build things. But another really important aspect to think about is real world performance, and is what we're building, what we're designing, actually what's getting built? And the answer is probably not really. You can see they've got mind the gap. So the performance gap between what our expected performance is based on our designs, our design stage SAPs, and then what is actually the building is achieving. And I've also got their thermographic image that's taken by one of our team. You can obviously, at the end, can you tell if that building is built in accordance with the U values? Have they installed the mechanical and electrical equipment properly? So they've noticed this because there's been poor build quality just on and off throughout the years, and what it's resulted in is higher bills for the occupants. So we really want to try and to make, obviously, to move forward towards this net zero target. I really feel like this is going to be a massive focus in the next few years, because we're going to get the design so good, but it doesn't matter if you don't build it correctly and it doesn't actually perform in the real world. So what the Future Home Standard consultation is suggesting is that we go for voluntary post-occupancy performance testing. Could be a little bit tricky because you're obviously going to have to get the occupant to agree to it. And how they're going to do it is use what's called smart meter enabled thermal efficient rating, SMETA. But it sounds complicated, but I think it's basically a smart meter, and then you pair it with some sensors in your house so it can actually work out how your house is performing. This would be obviously voluntary, but what they're going to try and incentivise this by offering developers who opt into this something called the Future Home Standard brand. So you'd actually get a stamp of approval to say, yes, we build our houses like we say we're going to. But obviously the proof's in the pudding. You've actually got to prove that you have. So yeah, this is what they're proposing. Again, this is all in the consultation, so they're welcoming feedback on this, but they've really noticed that this is a key thing that needs to be addressed as we move towards our net zero target, because it doesn't matter how well we design something, if you build it badly and when it's an operation, it's actually giving off loads of other carbon emissions, then it's not great at all. They're also talking about having increased commissioning requirements, so making sure that it's really commissioned properly, so that, especially for things like air source heat pumps, so they really work effectively. So there's quite a big focus on that in the consultation, and I think those of you who work with Part L 2021 and know about the photographic evidence, it's sort of like an extension of that. We are now having to take photographs of everything that's during the build, and then these photos are actually given to the house buyer, the first occupiers. So they're going to see, oh, is there insulation on my wall? Yes, that's good. Because I actually, when I opened up my wall to put a bifold door in, there was no insulation in my wall. So yeah, there's things like that people don't know, but they're trying to inform the house buyers now that actually, how their house has been built and how it should perform. So that's sort of the Future Homes consultation. One of the big changes with the Future Home consultation is that there's going to be no more use of SAP. So SAP has been around quite a long time. They're going to replace it with what's called the Home Energy Model, or HEM, and it is a complete reworking of the way we calculate building energy. And it's quite important because over the years, SAP's been used and sort of changed, obviously updated every so often, but the main mechanics of SAP have very much changed, stayed the same, and it's quite when you look at it, although I wouldn't say it's easy to do, but it's quite a basic calculation in terms of thermal elements, things like that, and it started to be used quite a lot. People ask us, what does a SAP calculation say? How much energy can you use? And that's not really the point of SAP. SAP is a compliance tool to get you the ticking box for Part L and get your EPC. The home energy model is going to have a bit more of a core engine that looks at things in a bit more detail. We're going to have to put more detail into it, but hopefully we'll get a little bit more detail out. And this is what they've got, is they've got the home energy model in the middle. That's like the core engine. So this is the little graphic that actually I've taken straight from the Future Home Standard. I took this one, not from the Future Home Standard, the wrapper. So basically inside is the home energy model, and surrounding that, they're going to be able to put different wrappers. So in the middle, it's like the suite, and then the outside is the wrapper. So you've got there the Future Home Standard wrapper. So they create a Future Home Standard wrapper, and you'd use the home energy model in the middle, and then the output would say, yes, you comply with the Future Home Standard. Then they're also proposing an EPC wrapper. So we'll still use the home energy model to get the EPC out, but there'll be a slightly different set of assumptions and way that it works. So, this is supposed to be open source Python script, so people can look at it, a bit more access. SAP was obviously very controlled. So we'll see how this goes. There is actually at the moment a beta version you can go and try if you wanted to. To be honest, it doesn't work very well, but I'm sure we've already gone back with some comments saying this doesn't work, and obviously they're developing it, but this is in progress at the moment, and this is what's going to be used. So there'll be no more SAP. We're all going to obviously have to learn how to use it and then help our clients with how to interpret the results. I've just gone through because there's actually a whole consultation on the home energy model as well. Lots of information for those of you who are interested, but I just wanted to go through some of the main changes we're going to see as we move from SAP to HEM. So Firstly, occupancy. Occupancy in SAP was previously based on floor area, and they're actually proposing in the home energy model to base it on number of bedrooms. So it's a bit more realistic. Again, hot water demand is going to be more accurately based on occupancy. And because we've been obviously introducing a lot of low flow appliances for compliance with Part G and London Plan, actually the hot water demand has actually gone down. So they're actually going to be reducing the hot water demand assumptions in the home energy model. The carbon emission factor, there's some small numbers there. Currently, we're assuming 0.136 kilograms of carbon per kilowatt hour. The future home standard is going to assume 0.086. So it's gone down again. Bearing in mind, back when we were doing SAP 2012 or Part L 2013, it was 0.519. So we've massively slashed the carbon in our electricity grid, and we know that because we've been decarbonising the grid, increased use of wind, things like that, which we'll go into a little bit more in a minute. The weather. SAP used East Pennines, which is absolute worst case far up in Scotland. Future Home Standard is proposing to use regional data. There'll be a lot more opportunity to put in innovative technologies. At the moment, it's very poorly executed in SAP. If there's something that doesn't fit the box, you can't. It's very difficult to get put in. They're going to expand Appendix Q and make things because on our sort of drive to net zero, we're going to have to use more innovative technologies that are coming out. Like, there's probably things we're going to use in our homes that we haven't even been designed yet. So we need to be able to adapt and get those in so that they can be accounted for in these net zero homes. Pipe network lengths are going to have to be measured in the future home standards. So we're lucky here at Whitecode, we've got a really supportive MEP team who, we can work with on that. But there's a lot of extra work for us to do in terms of making this home energy more accurate. Time steps currently in SAP are monthly. For future home standards, it's going to half hourly. So a bit like more like an overheating assessment where you do an iterative time step of half hour. This is going to be half hourly. What we've seen is that running a home energy model against the future home standard, it's more like a simulation. With SAP, it's instant. You just change something, you see the result instantly. We're going to be inputting information for the HEM and basically clicking start, and it will go blip, 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 all through the half hourly for that particular weather data for that year. So there'll be much longer to do it and more time to get the information out. Bit more work for us as well. We won't be able to call ourselves SAP assessors soon, but HEM assessors. In SAP, we sort of put in one type of window, say this is the U value and G value, but actually individual windows can have different U values and G values and frame factors and everything, and we're going to have to individually measure them and put them in. So there's going to be a lot more work involved, from the calculation side as energy assessors, but also we're going to require a lot more information to put in from the design team. Bearing in mind some of this needs to be done at pre-planning stage, it's going to need to be done for planning reports potentially. The amount of work is just going to be much higher. Before I hand over to Alex, who hopefully is here, I just wanted to have a quick note about EPCs, because EPCs have been a tool that people have started to use more, I'd say, in the last few years. And we've noticed that there's a push to get EPC rating from our clients. They're saying, we must have a minimum at B, or we'd love to get an EPC rating of A. And it's really, these EPCs should be used as a tool to guide us through our net zero carbon. But they're not, because at the moment, someone who has a gas boiler is going to have a B rating. If we swap it out for an air source heat pump, it's probably going to go down to a C rating, and that is not encouraging low carbon transition. So they actually need to sort this out in terms of EPCs. Me and my colleague went to a national conference on Tuesday, and there was someone from the government there talking about the EPC reform bill and basically saying they need to change the EPCs, but they also need to be quite careful, because a lot of policies a lot of companies have already, set up some guidance on their based on EPC ratings. So, and funding based on EPC ratings as well. So it's really important to make sure that EPCs are correct. So yeah, that was my whistle stop tour of the future home standard. Alex should be there. Hopefully you can take control, Alex.
Yep.
Oh,
should
great.
Be there if everyone can hear.
Yeah, can you take control?
Yeah, I think so. I've hit the take control button, waiting for approval. You need to approve me.
I was about to click deny, then give control. There you go. Yeah.
There we go. Okay, so hopefully, so I noticed we've got some air source heat pump people that I know on the presentation. So there are some energy challenges that I'm going to talk about. This is stuff we can do things about, and there's some stuff we can't do much about. But this hopefully will give everybody a bit of information as to the problems we're all going to have. So the fundamental problem with heat pumps is the link between electricity and gas. Now, this presentation was written a few months ago. These were the rates then. I know the rates are coming down. But what's not happening is the difference between gas and electric. Now, with seasonal efficiencies of heat pumps, we've seen operationally around 2.3, and that's 2.3 times of its efficiency. Electricity is still more than 4 times that of gas, which means that the retrofit market for heat pumps is going to be we're going to need to deal with the issues with our grid before it's going to make heat pumps cost effective to run on existing systems. In new builds where energy is low, where they're supported with PV, it makes sense. I'm doing it in my own house build. But the retrofit market, we need to be very careful that people like British Gas saying come and fit a heat pump because it's efficient. People deem efficiency to be cost to run, and actually just from these really very simple maths, it's going to cost you potentially 40% more to run your heat pump than a gas boiler. Hopefully, next slide. Okay, so the other problem that we've seen is we've got some schemes with air source heat pumps where the heat pump lifespan has been an issue, where particularly with the development of refrigerants, where heat pumps effectively go out of date quite quickly and seem to be more complex than a simple boiler, which in fact has some very small moving parts. And seems to be forever interchangeable. So we've seen the cost versus the retrofit market, where you can buy a boiler for £1,000 against a heat pump of 6, and we're talking. That example is an external condenser with an internal unit. So we've got a life expectancy that we've seen operationally lower compared to gas boilers, and the capital cost is significantly higher. And really, although the government is pushing heat pumps from an efficiency basis based on existing properties, the numbers just don't stack up. And until heat pump suppliers start to reduce their external costs down to what you can buy a VRF external condenser for, there's still going to be quite a disparity between the installation of a heat pump against the gas boiler. And I do know people in the trade are talking about buying lots of gas boilers before they're made illegal, because it's a significant cost difference between the two. The other problem that we've got is the actual installation of these things. So currently, well, according to the government, last year we built 230,000 homes with a target of 300,000. But their target for heat pumps is to install 600,000 by 2028. Obviously, the difference is made up in the retrofit market. We actually only installed 55,000 in 2022. The problem that we've got is that there's very few people at the moment that are F-gas qualified and are able to fit these heat pumps. So we've got a big challenge to upskill our labour market to install the right amount of heat pumps and be able to change components. Now, some suppliers are dealing with this very easily by saying, well, actually, we're not going to service the refrigerant parts within my heat pumps. We're just going to swap them out. And that we're going to need to develop as the market develops and the products develop. But we do have a massive skill shortage when we've only got roughly 2,000 F-gas qualified people in the UK, and we want to get to 600,000 heat pumps. So there's going to have to be a massive shift towards refrigerant as effectively we wean ourselves off of gas. So this is my favourite slide. This is the M&E engineer's pawn, as I like to call it. This is the national grid at a peak time over winter, and we've got roughly 40 gigawatts of demand. And when I spoke earlier about the cost of gas being the cost of gas being 4 times that of the cost of electricity 4 times that of gas. This is all to do with the grid mix. So this slide really just shows you that at peak times, and if you can see my little pointer there, in peak times, the national grid is still using CZGT, 53% of it. What does CZGT means? Combined cycle gas turbines. We are generating half our power at peak times from natural gas. And until such time as we stop using natural gas, we're not going to break this cycle between when the gas doubled when Russia took a dump on the Ukraine, that our electricity went up by 50% because of the link between gas and electric. And the worrying thing is some of these smaller parts of this slide that you can't see, that actually we've started to turn back on our coal-fired power stations because we've closed down lots of asset. Dartford Power Station, quite local to here, has been knocked over, replaced with, you guessed it, nothing. So we've reduced our installed capacity. We've taken off things like oil. We've kept some capacity, some of which is designed to be switched off in 2026, which we're now talking about potentially having to leave back on some other oil and coal stations that were due to be decommissioned, because there is a crunch point in our demand. And I'll talk a little bit more about that on the next slide. So max capacity at peak times is around about 42 gigawatts. In fact, last winter we had 2 situations where we were so out of power, where they had something go wrong in a power station and turbine didn't fire. We had to emergency import power from Belgium at a significant cost. And the head of SSE said to me, I said, look, have we got a problem? And she said, absolutely. So we're going to talk about electrification now. So if we take a standard gas heated home, there are 24 million of them in the UK, roughly 25 million, depending on what you read, that we work on the basis of it using 1 kilowatt of electric across 1,000 homes, when we scale it up. Now we think about our new build homes, that we're going to probably have a heat pump. According to the consultation that Ellen's just mentioned, probably not going to have PV, which is, in my opinion, nuts. Then we're going to add in our heat pump. Okay, let's say 5 kilowatts for a house. Let's add in your car, because by 2030, most car manufacturers are going to stop making petrol engines. So therefore, let's add that all together. And that's 12 kilowatts of electric that could quite feasibly be operating at the same time. It's winter, your heat pump's on, you're charging your car, and I've been generous with only a 7 kilowatt load, and that could potentially mean we need 12 times more power for each home we build like this. Put it another way, we add, every time we build 230,000 new homes, 1.4 gigawatts onto our problem. Now, when we diversify that load, it's all not going to be happening at the same time, but the head of UK Power Networks that's looking at his grid capacity said, we've got a problem. We've got a problem because the electrical demand, which for years and years and years was tailing off due to energy efficiency, today is going the other way due to the electrification of both our heating and our car charging. And actually, probably the biggest effect on the UK national grid is vehicles. So I'm going to introduce you all to a term that anybody that's here that's old enough will have heard. Will have heard the term load shedding. So in 1973, the winter of discontent, we had coal miners on strike. They were refusing to pull the coal out the ground. Most of our power stations were coal or oil, and we ran out of coal in our power stations. That meant that our installed capacity suddenly went down, and we had no choice but to load shed. Now, those people here from Whitecode will have heard load shedding because our office in South Africa, and the picture on the right is me in South Africa with 2 candles in a property that was experiencing load shedding. So load shedding is where we turn off the power for 2-hour windows to share the installed capacity. South Africa has a 5 gigawatt problem, and according to the Telegraph 2 days ago, they are predicting that we will have potentially the same issues in winter 2028, where actually we may run out of power. Now, interestingly, the UK is potentially dealing with this in a very innovative way. So the first thing that we're considering doing is paying people to switch their power off. So I've been part of a trial with Octopus Energy to use less power during peak times and get paid for it. So this smarter energy use within the grid is something that people are very much considering, coupled with people like British Gas and Centrica that are looking at batteries that they can control centrally. We may not experience load shedding, but 2028 is a very short period of time away. So we do need to be very careful pushing hard down the heat pump route for the existing property network as well as new build, because we might just run out of power. Next slide. I want to talk about something that isn't spoken about much and not very many people know unless they're in this field, and that is hydrogen. BMW have said they're going to close all of their electrical vehicle plants and they're going straight down the hydrogen route. And I think it's important that hydrogen may well be a very good solution to our existing network of gas, which at the moment we blend gas. We have natural gas. In the 70s, we spent 10 years switching over from town gas to natural gas. And perhaps one of the routes to decarbonising our existing homes is hydrogen. Hydrogen is a gas which we can burn. The only byproduct of hydrogen really is water. The problem is how we make it. There are 2 types of hydrogen. We've got blue hydrogen and green hydrogen. Blue hydrogen, we use natural gas molecules and we split out the hydrogen molecule out of that. So we take the gas out of the North Sea and we make hydrogen. Uses a lot less energy than the next form of hydrogen, which is where we pull out the hydrogen molecules out of water using electrolysis, which is very, very electrically powered. But if we power that electricity from, say, wind turbines, then it's highly sustainable, hence the 2 terminology, blue and green. Unfortunately, the government isn't really legislating or trying to improve the situation with hydrogen. At the moment, we push 3% hydrogen into the national gas network. So our boilers by design can burn currently over 20% hydrogen if they need to. So we could just blend more hydrogen into our network if we could make enough of it, and try and decarbonise our existing boilers. By 2025, domestic boiler companies are telling me they will have products where they can switch 3 components within their boilers and go 100% hydrogen. So it is feasible that the existing gas network could be utilised for another purpose. Unfortunately, the government isn't tuned into this, and they have started and created a hydrogen roadmap, which they swiftly withdrew. It was out for a year, and this was trying to give some certainty to producers of hydrogen and those people manufacturing the plants. However, there are companies out there that can see this as a form to create energy in very small footprints. So, for example, opposite our office, the Kimberley-Clark plant's put in plans to extract a very large amount of hydrogen from water. it's very important to say, although heat pumps are very good at what they do, they require a large footprint to create energy and heat, whereas hydrogen uses a similar footprint to that of gas. So from you know, the retrofit market, and even those that are trying to create a large amount of heat, probably heat pumps are not the solution. But with the government still in limbo with hydrogen, unfortunately, it's probably too far away for us to even consider it as an option. And in fact, I think Ellen mentioned that hydrogen doesn't even feature in any of the consultations for the new energy models or the calculations, and therefore it's not even on the government's radar. And we, as I've pointed out, we need to be very careful with our installed capacity within the national grid, and the government is in fact probably sleepwalking into a big problem, um, uh, and there is a potential other mix to this solution, i.e. hydrogen, that it's not even on their radar, which is highly disappointing, I would say. So there are some real challenges with our energy in delivering some of the models that Ellen's just gone through, because we're not thinking about the whole problem holistically. So yeah, my lasting message is that we do need to consider other technology, as well as pushing hard for things like heat pumps, before selecting this as the solution to all our problems. I certainly wouldn't be recommending anybody swap a heat pump from a boiler without energy efficiency or the support of PV to reduce the cost, which none of the large you know, gas replacement boiler companies are talking about at the moment, and I think that's pretty disappointing, because I've had many clients ring me up saying we swapped to a heat pump, my bills are high, and I've got and I wasn't expecting it. And when you run through the maths with them, no one's done that, and so we could be walking into a situation where, and I don't want to be there, where heat pumps are fitted and then they're removed again. You know, we need to be honest with people, and we need to have honest conversations, and we need to break that chain between gas and electric, and stop making our electricity from combined gas turbines to try and solve these problems before it's all too late. I think that.
There's one more slide, isn't there?
Yeah, yeah. Sorry, it's not changing because my mouse is gone. Hold on.
Yeah,
There
that's
we
just the
go.
final slide. Yeah.
Yeah. So the final slide. So what's the future of energy in 2025 and beyond? So building regulations, future home standards are pushing us down the heat pump route, which is you know, fine, but there are issues with capital cost, supply and power availability, and we have seen sites where we have real issues with power availability, and we need to use heat pumps. So this will become a bigger problem for the grid as we switch to this technology. Like all good design guides, we must focus on fabric first. For me, that is not just new build. We are dealing with lots of retrofit, and part of this improvement must include the improvement of the fabric before we fit a technology such as a heat pump. And we must also remember that we build 230,000 homes a year, but we've got 24 to 25 million stock, which a good majority of them use gas boilers. So we mustn't forget that when we're legislating. Hydrogen rollout, I think, needs to accelerate, needs to be included in the home energy calculations, and would be a great solution for decarbonising existing buildings. And in our opinion, it's nuts that we're not being legislated to put PV on the roofs. See previous note about installed capacity. PV and a battery system in all new homes that could be centrally controlled by your energy provider, for me, could avoid load shedding. Okay. Thanks, everyone. Are there any questions?
Amy was having a look at the questions for us. Is there any, Amy?
Yes, there's a few questions actually. So just, well, firstly, will the slides be available after this?
Yeah, we can send out the slides, no problem.
Secondly, so Darren says, as the COP is only based on the heat pump, should there be a measurement of the entire heat pump system, such as the specific performance factor, or sorry, seasonal performance factor?
Yeah, I think that would be better, don't you, Alex?
I think that's why they're looking in the home energy model to calculate all of the pipe work. There's going to be some kind of fudge to look at the actual length of pipe work, you know, much like in the passive house standard, where you've got to keep certain things close to keep the energy and the performance up. I feel like there will be another series of factors where we're told, you can't have your air source heat pump 10 meters down your garden. You know, that will give you a negative effect in home energy model. It just makes sense that we start thinking about the whole system now when we're thinking about heat pumps, because the problem is we've all seen people like, you know, other manufacturers saying my external box has got a COP of 6, but when you stick the seasonal efficiency in, we're seeing a 3, and in actual operation we actually see 2.3, and that for me means that the assessment of the seasonal efficiency and the operational efficiency, like Ellen said, we've got to close that performance gap.
Yeah.
He also mentions sort of that they've had discussions on a pink hydrogen using nuclear, and France have been pushing for it, and just asked for sort of like maybe a conversation with us regarding that.
The big problem is, like everything, that the electrolysis to get the hydrogen out of water needs a huge amount of power. So it would make complete sense for a nuclear power station to have a ginormous, you know, electrolysis creator, because you can make a lot of power from nuclear. So that seems like a very sensible option to me, because the big problem that we found with our grid is when the wind doesn't blow and it's not windy, all the wonderful wind farms that we are actually the fastest installer of in Europe don't produce any energy. So we've got to have an energy mix in the UK that will operate when there is no wind and no sun. And if we are going to make so much hydrogen, and I think we really are going to need to make so much hydrogen, yes, nuclear makes sense. But one thing I would like to say, and one statistic I'd like to give you, what we don't want to be doing is giving Rolls-Royce £500 million to make mini nuclear power plants, when that £500 million could be given to end users such as you and I to put free PV on your roofs. Because actually I worked out, I think you can probably get 25% of the UK with PV on the roofs for those kind of sums. It just makes sense at the moment to reduce our electrical demand, and then we can use some of it for technology such as splitting out hydrogen. So yeah, I agree. But all I would say is it takes 30 years to build a nuclear power plant. 30 years. Another statistic for me, which is why I don't like nuclear, that in 1983, Chernobyl happened. Reactor, and I can't get the numbers A, B, or C, the reactor that blew up is still not decommissioned. And it blew up in 1983, you know, and was switched off, but it's still got a shield on it, and they're still trying to decommission it. You know, really, is that the technology we want to be putting in our property? It is horrendously expensive. You know, for me, there must be a better solution. And I think thinking about energy in a different way, you know, when it's windy, we overproduce electrical energy. Capturing that energy in a simple way, like pumping, you know, water up a hill into a reservoir and then pumping it back down again when we've got demand, is a simple method of storing electrical energy. We're just moving it in a different way. So I don't necessarily agree that we should be launching around putting nuclear power everywhere, because it's a 30-year decision, and unfortunately our politicians won't make that decision in a 4-year political cycle, which is why we've got a problem now.
Yeah, I think Darren Darren, myself and Molly actually came to see you, didn't we? He's from Renai, and they have hydrogen. He's saying they've got hydrogen ready boilers and units already capable of up to 100% hydrogen. So yeah, it'd be good to have a bit more of a chat with you, Darren.
And the point is, but nobody's talking about hydrogen. You know, BMW, the first people to go, do you know what? This battery stuff is not going to work. You know, for us, it's too expensive. It doesn't last long enough. It's not hugely sustainable to mine your nickel from Canada, ship it to the Far East and back again. And actually, we've got something oven ready, excuse the pun, that we can burn in the same footprint. So I think that all the boiler suppliers that I'm talking to are shouting from the hills, hydrogen, hydrogen, hydrogen. And the government is only hearing heat pump, heat pump, heat pump, which I think is a mistake.
Right. Well, we have got a couple more questions, but we'll probably just go back to those after, so we're a bit over the time. But thank you everyone for joining. And yeah, we can send out the slides. Obviously, if anyone's got any questions regarding anything regarding future home standard, MEP design, anything like that, then please get in contact with myself or Alex. I'll add on to the slides actually our contact details, so you can give us a call or drop us an email if you want to speak to us.
Cool.
Thanks very much. See you later. Thanks. Bye-bye.